So today we're going to be doing a quick intro on independent and dependent quantities. The problem you just went over on the left side of your handout, having to do with video games and hours spent, is an example of a situation that's independent and that has independent and dependent quantities. So here are a few more examples, and let's see what they all have. A student's grade depends on how much they study, the height of a plant and the amount of you water it, the amount of money you make and the number of hours you work, the number of sodas you buy and the total money spent, the number of houses you can paint depends on how much time you have. So these are a few more examples where all these situations have an independent and a dependent quantity. So let's just kind of get into the idea is there are two quantities that are changing in each situation. When one quantity depends on another in a problem situation, it is said to be the dependent quantity because it depends on it. The quantity that the dependent quantity depends upon is called the independent. So we're going to fill in some definitions now. You should be writing on the right-hand side of your handout, filling in all the blanks. So the dependent variable is always located on the x-axis, on the y-axis, of a graph. So it goes on the y-axis because it comes second. Independent will always come first because the dependent depends on the independent, so which comes first. So dependent comes second, it goes on the y-axis. The dependent variable is the output. So if you're thinking about it as input, output, or xy, it's your y value, it's the output, which we call the range. The dependent variable depends on the independent variable, and the dependent variable is what happens second or last. Now for the independent quantity, we're going to fill in the same information. So the independent variable is always located on the x-axis. It is the input. So again, independent just happens on its own. It comes first. It's the input. The independent variable stands alone and does not depend on anything to take place. The independent variable is what happens first. So go ahead and take down those notes, and we will go ahead and go back to those 5 examples we just saw at the beginning and identify the independent and dependent for each. All right, let's go ahead and practice some of these. So the first one was a student's grade depends on how much they study. So we have 2 things going on here. We have an independent and dependent quantity. We're going to decide which one's independent and which one is dependent. So we have the 2 ideas of the grade and the amount of time they study. So we have the grade they get and how much they study. So which one's going to come first, the grade or how much they study? Generally, you will study first, and then you will earn a grade based on how well or how much you studied. So in this case, the independent thing is how much you study. So you can choose how much you're going to study, and that's going to affect your grade. So our independent in this case is our time studying, and our dependent quantity is our grade earned. So let's go ahead and move on to the next one. We have the height of a plant and the amount you water it. So we have 2 things happening, which is the height of the plant, how tall it grows, and the amount we choose to water it. So 2 things are happening here. Which one comes first, the growth or the amount we water it? So in this case, the height depends on how much water is being fed to the plant. So height comes second and water comes first. You can control how much water goes into the plant, which then affects how much it's going to grow. So water comes first, which is our independent, and our dependent is how much it grows based off the water. So the height depends on the water. Let's go to the third one. It says the amount of money you make and the number of hours you work. So we have 2 quantities here. We have the amount of money you have and the number of hours you work. So which happens first, the money you earn or the working itself, the hours you work? So you're not going to earn money unless you actually work some hours. So what comes first is how many hours you work. The more hours you work, the more money you make. So hours comes first. money comes after you've worked. So the money depends on the hours. So we have our independent and our dependent. Hours worked, money you make, or amount of money. Next one, we have the number of sodas you buy and the total money spent. So here our two quantities are the following. We have the number of sodas we're going to purchase or we're going to buy, and the total money we're going to spend on these sodas. So which comes first? Buying the sodas, or choosing the number of sodas, or spending the money? So when I go up to the register, are they going to charge me first, or do they need to first see how many sodas I'm going to buy? So they can't charge me until they know how many sodas I want. So the thing that comes first is the sodas, then the price of the sodas. So money depends on how many sodas you're going to buy. So sodas comes first, money comes second. So number of sodas is an independent. The total amount of money we spend on those sodas is a dependent. The money depends on the sodas. And our last one, we have the number of houses you can paint. Depends on how much time you have. So we're painting houses, so the number of houses, whether we paint one house, two houses, three houses. And then our second quantity is the time you have. So which one comes first? So if I have 10 houses to paint, I can only paint 10 houses if I have a certain amount of time. I cannot just paint 10 houses and it's going to happen no matter what time. So if I have 5 hours, I can spend painting so many houses. So what comes first is time, because the more time I have, the more houses I can paint. So the number of houses depends based off of the time. And as a general rule, in 99% of the cases, time will always come first, or most of the time, the time is our independent quantity, because time will happen on its own. It's not restricted to anything. It's what we can get done during a certain amount of time that is dependent. So just as a side note, time will usually be independent. And that's pretty much it for that section. We're going to move on to the next thing. So this is the next page on your handout. You're going to be working on this one. I'm going to do the first one with you guys, and you guys can finish the rest. So let's just read the situation here. Have you ever planned for a party? You may have purchased ice, gone grocery shopping, selected music, made food, or even cleaned in preparation. Many times these tasks depend on another task being done first. So you can't put out your food unless you've actually made the food first. So here, for instance, you wouldn't have your food unless you first went to the store to buy the food. So some things depend on others. You can't buy the food until you maybe first made your list of what you're going to buy. So certain things depend on others before they happen. So here we have 5 situations, and I'm going to go over the first one with you guys. All right, so up at the top is just a definition of independent and dependent once again. So we're going to go ahead and circle the independent quantity, and we're going to underline the dependent quantity in our 5 examples. So let's go ahead and think about the first one. The number of hours worked and the number of money earned. So this is similar to the one we just went over. So the more you work, the more money you make. So in this case, hours will be independent and money will be dependent. So in this case, remember, this is an example of what I mentioned earlier, that time will usually be independent. So number of hours is independent, money earned is dependent. So now it's your turn. Go ahead and do the rest of them. You can stop the video now, or you can keep watching so you can check your answer for the first half of the previous page. So again, work on this on your own, but it's preferable to work with someone so you can discuss this. All right, so here's a problem you guys were working on earlier. So Emma bought a new video game. The graph describes the number of hours Emma spent playing the game over a period of 7 days. So as you see the graph, we know it took 7 days to play the game. So if we look at the x-axis, we see dots going across 7 times. But if we look at the y-axis, it only goes up to 4. So we should have data for 7 days. So in this case, that tells me that the 7 days should be my independent quantity, also because it's time, and the dependent quantity is a video game. So I'm tracking hours per day, so days would be my independent, and number of hours depends on the day. So let's go ahead and talk about answering these questions. So how would you label the x-axis? I would label the x-axis with the day of the week. So I would just write, I would label the x-axis day of the week. Or second one, I would label the y-axis as hours spent playing video games. And the next one, you would explain your reasoning in any number of ways. One way that I would say I labeled them this way because you can go off the points. On the x-axis, I see 7 dots going across, and I know there's 7 days. That's one reason you can say time is independent, which represents the days, and so on. What does the highest point on the graph represent with respect to the scenario? So the highest point on the graph, which would be at day 3, that would represent that on day 3, Emma spent 4 hours playing video games. Then the last one, what does the lowest point on the graph represent? Same idea, the lowest point on the graph would be on day 7, which is on the x-axis. That would say that on day 7, Emma spent no hours playing or 0 hours playing video games. All right, that's it. Now go ahead and finish up your assignment.